recall when we did limits, of course, you plugged it in and you either got a number or one of these two indeterminate cases. Okay? And we had in our bag of tricks a couple things. If we got 0 over 0, we could factor and cancel or multiply by complex conjugate dependent upon the problem. All right, so what about this thing in blue? I told you it's another way to do 0 over 0, okay? But you needed to know how to do derivatives to use it. Well, now you know it. So let me show you one problem there, and this is gold. Okay, see problem 1? All right, problem 1, back when we did this one, we factored the top. What was it called? Oh, I'm sorry. We plugged it in and got 0 over 0. Then we decided to factor and cancel. What's the last step? I call it the replug. And the answer is 5. All right. Now look, you've been factoring since Algebra 1, long time ago, and the group I'm talking to now probably pretty good at it. All right. However, all right, some of you may not like factoring so much. And at any rate, it's always good to have a second method. Let me teach you L'Hopital's. Okay. And can you hear me? I should have asked that too. Yay. All right. So guys, here's L'Hopital's. L'Hopital's rule says if you get 0 over 0, you could take the derivative of the top. All right, let me have it. What's the derivative of x squared? All right, and okay, we're doing this in parts, right, using the power rule. So the derivative of this is 2x to the first. And what's the derivative of negative 5x to the first? Type or say the derivative of that. You remember your power rule. Okay, so the one runs out front, gives you what? Negative 5x to the 0. Okay, so you've taken the derivative of the top. All right, now take the derivative of the bottom. What's the derivative of plain old x to the first? Not going to get easier than this. 1. And what's the derivative of a constant? Poof. Okay? The L'Hopital says take derivative top and derivative bottom. Now plug it in, and you'll see double 5. That's 10 minus 5. The answer, which we already knew was 5, is 5. Okay? So this problem right next to it, let's do L'Hopital's there. Take the derivative of the top, derivative of the bottom, and plug in the 1. And tell me what your limit is for this problem. right, anyone got it? I'll give you a minute. Okay, guys, the derivative of the top is 3x squared, and the derivative of this constant goes away. On the bottom, just like the one over here, the derivative of 1x to the first is just 1, and this goes away. All right, now do the plug-in. And your answer is 3. All right, so that's called L'Hopital's. Okay, without L'Hopital's, sure, you could have factored using SOAP, canceled, and then plugged in 1 here and still gotten 3. All right, but it's a good method. All right, and make sure when you do this on the AP test next year, all right, you have to say that you used L'Hopital's. Okay, if you just magically come up with the answer, even if you clearly did L'Hopital's, they're not going to give you full credit unless you do. Okay, so that's derivatives and limits. A look back. All right, so what's today? I don't think we're going to sing today. All right. Today we're going to do integrals. What does the name antiderivative kind of suggest to you? All right. Suggests that we're going the opposite direction of a derivative. Okay, keep that in mind. All right. So what is an integral? Well, let's start with the notation. It's going to look like this. All right, this symbol means integral. You could have upper and lower bounds in this function. And all this says is there are x's in that function. All right, so that's the notation. And here is your first rule. And I got to tell you this. All right, if you look in a textbook or Google it, all right, there might be, I don't know, 119 different integral rules. Do we really have to memorize all this? Highly doubtful, all right? But unlike derivatives, where I only gave you 5, techniques, all right, this one, there's crazy amount, all right? I'm going to give you 2 today. All right, the main one and one special. So here is the main one, the special one's coming later. All right. All right, memorize this, nice and easy. All right, to take an integral of this function, which looks like power, think. What were the things you did when you did power rule and derivative? I believe you multiplied and subtracted. Well, this won't shock you. What do you think the opposite of multiply and subtract will be? Divide and add. Okay. Now, one other little thing, you got to put a plus C after every integral problem that's not a definite integral. All right. This thing is so important. Okay. If your AP test question is worth 3 points and you haven't a clue in the world and you just put plus C, you got 1. Okay. And to be certain, some people forget those all the time. You lose a point every time. So the plus C is for an unknown constant. All right. Hopefully but I'll stick with you. So let's take a look at a silly, easy problem. All right, we want to take the integral of 6x squared. Okay, so here we go. We got to do what? Instead of multiply and subtract, we're going to add 1 and divide by that new exponent. So what do we get when we add 1 here? We get 6x cubed, and we're supposed to divide by our new exponent, which is 3. All right. Yeah, I know, plus c, but let's simplify. What do you get here? 2x cubed. And then you put a plus c after it, and you've got yourself a completed integral problem. Easy enough, right? Okay. So instead of multiply and subtract, we will be adding and dividing. But just to give you a little discovery learning here, all right, let's say I started you with this and wanted to go this direction. All right, what is the derivative of this guy? Type in your answer. Yep, 6x squared. And then what's the derivative of this constant? Poof. All right, so do you see how that works? If you take the derivative of this, you get 6x squared. If you take the integral of this, you build it back up to 2x cubed, but we don't know if there was a constant after it or not. So we put a plus c to take care of that, okay? Very good. How about, hope I gave you a U try here. Let me. Might have to make one up. Yeah, let's. Nah, you know what? We'll do this one. Okay. All right, guys. So I want you to take the integral of this, and remember, it's in pieces. So please do integral of that guy, just like you did up here. All right. What do you get when you do the integral of that? Remember, add and divide by the new exponent. What does that give us? And if you think you got it, try these two next to it. All right, it's 2x to the what new power? 6, and we're going to divide by 6. All right, try it again. Do integral for this guy. Okay, it'll be what? 8x to the what power? correct? And you divide by your new exponent. To be sure, we will simplify that. Now, this one is very easy, but it's a most missed. Right now it says what? 6x to the not even there. So go ahead and do a quick integral on that, and we get what? 6x to the what new power? Okay, and then we're supposed to divide by our new, and then we'll end by putting plus c. Okay, all right. Well, the only thing you really got to do is simplify it. This will be what? 1/3 x to the 6th plus, what's 8/4? That's 2. And always take care of these ones. And that's it. Okay, so this would be the integral of this in green. All right, and show off a little bit, please. Do you see what I see? What happens if you took the derivative of this? 6 times a third is 2x to the 5th, right? Because you subtract one. This would be what? 8x to the third. This would be 6x to the 0. And what happens when you take the derivative constant? It's gone. All right, so you can kind of check yourself when you do that. All right, so there is an expanded problem. All right, now if we were in class, I'd be giving you some extra special ones. And since we are not there, I'm going to give them to you right here. All right, supposing you're definitely going to see this problem if you're in calculus. Okay. Now your first guess is to add 1 to the exponent and divide by it, blah, 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 blah. All right. However, if you were with me last class, you remember I told you there's 2 things that calculus don't like. This is one of them. All right. I said every time you see x downstairs, you need to rewrite it so that it's upstairs. So this is now x to the negative 4. And now we could do our integral there. Add 1. What do we get? X to the negative third over our new exponent. And there will be a plus c after it. However, calculus, bless its heart, all right, it didn't like the x downstairs. Well, it don't like a negative exponent either, so it wants you to put it back downstairs. Okay, welcome to calculus. So this would be the actual full credit answer for that one. Okay, so remember, just like last time, calculus does not like the power down in the basement there. All right, and maybe you remember one other thing calculus doesn't like. All right, hang on, struggle bus. Hang on. Hanging on. All right. And that'll be with you in just a minute. Oh, so sorry. Continuing with problem. All right, I'll work it here. All right. Sorry about that. All right, supposing you had this problem. Okay, calculus doesn't like the radical bar. All right, so again, before you did this problem, you would have to rewrite that as x to the 2/3. Now, why is that important? Because that's the technique I showed you. How can you add one to an exponent if you don't have an exponent? Okay, so real quick, can you add one to that? What fraction do you get? Two-thirds plus 1 is 5/3. And we're supposed to divide by our new exponent. Okay, if I divide by 5/3, that's the same as what? Multiplying by 3/5. And that, with the plus C, is the answer. All right, so yeah, the only thing you're not going to get this year is practice. All right, but at least if you showed up today, you will have seen this. Okay, good. All right, so that's the main rule number 1. All right, and now I'd like to show you a special case. All right, if you see this, the answer is going to be ln. You remember ln, don't you? Okay, ln of the bottom plus c. That's it? That's it. Okay, now, like I said, there's 135 of these things. All right, how are you going to memorize that one? All right, well, I don't think you do. I think you try to do this problem the way I just taught you. All right, what did I say you had to do if it was down here? You had to rewrite it as x to the negative first, right? All right, so look at this one. Now, what wacky thing happens if you do what you're supposed to do by moving that up top? Can you add 1 to this? What do you get? X to the 0 over 0. All right, and x to the 0 over 0 is confusing. Okay, you're not supposed to have 0 downstairs. You know that. All right, so that is not the answer. All right, by definition, you're going to just take the natural log of the bottom and put plus c. Okay, so there's a special case. All right, only 128 to go. All right, but I'll save something for next year for you. Okay, all right, what's left? U sub. Okay, now I gotta tell you, this is advanced. So I hope you have your thinking cap on, but this is gonna separate the A's from the retakes next year, U sub. All right, and you will know it before we even get to summer. All right, supposing you got this problem. Okay, it's starting to get a little tougher. All right, and we don't have a rule for something like this. Now, could we, bite my tongue. All right, could I FOIL this 5 times and then distribute a 2x and then do it piece by piece by piece? But yes, I could. Okay. However, I'm here to show you a little technique called U sub that's going to make this nice and easy. All right. If you get good at this, all right, you will definitely have a strong calculus year. Okay. But here's how it's done. This is your brain over here. And you're going to think when you eyeball this, we're going to try and rename things. All right. The first thing you're going to do is rename something U. Okay. And since you've never done one of these before, you have no idea. So I'll tell you, let's call that U. So in my brain, I'm saying U is x squared minus 1. With me so far? All right. Our goal is to rewrite this whole sucker so that it doesn't have any x's in it. So real quick, what's a new name for this? What's a new name for x squared minus 1? U. So this is now U to the 5th. Okay, with me? Okay. Now, if we try to do the problem, we still have an x there and an x here. No good, no good, no good. Okay. So we got to do one more step, and it's back to our brain. All right. Now that you've told me what U equals, all right, the next step is to tell me what the derivative of U equals. Now I'm going to use that form instead of dy dx. Okay, I'm going to call it du dx. All right. Real quick, guys, what's the derivative of this up here? What's the derivative of x squared? 2x to the first. Very good. And of course, the derivative of -1 is 0. So that's gone. Okay. So look what we got here. The derivative of U is 2x. Okay. Now watch this trick. What if we multiply both sides by dx? It kills that one and brings it over here. All right, and this is it, the most important 3 seconds of the whole lesson. 2x dx, 2x dx now has a new name. All right, so eyeball this right here in purple and green. Do you see any x's anymore? No, you don't. So you're allowed to take the quick integral of that guy. U to what new power? You guys struggling to add 1 here? Come on. U to the 6th over 6 plus c. All right. And now the only other thing they're going to want you to do is put the x's back in. All right. It wasn't U. It was really what? X squared minus 1. So this is the integral of this original problem using what's called U substitution. Okay? And again, you definitely need practice with these. All right. But unfortunately, I don't have worksheet ready to hand you like I would if we were in class. Okay. All right, guys. Last thing of the day, last thing of the year, integrals of the, I want to do that. Let's talk about definite integrals. Right now, we've been doing, well, to this point, we've been doing indefinite integrals. What's different about this problem from everyone we've done so far? It's got an upper and a lower bound. Okay. So how is this different? Well, 3 easy steps. Okay. Step 1, you're going to take the integral of that. All right. Get your practice. What is that going to be when we take an integral of it? Okay, add 1 to your exponent and divide by your new exponent. And it looks like the integral is just plain old x cubed. Okay, now look, if this were an indefinite integral, you would have put plus c and gone on to your next problem. Okay, however, since this is a definite integral, here's the extra steps you're going to want to do. All right, step 1, you took the integral. All right, step 2, all right, they're going to have you draw this line and put the upper bound here, lower bound there. Okay, this is just the way they write it. All right, what's the actual technique? You're going to plug in the top and get what? Okay, very good. So 5 cubed is 125. And now guess what you got to do? Plug in the bottom. 2 cubed is 8. And when you subtract those, your final full credit answer is 117. Okay, so to recap, how do you do a definite integral? Take the integral first, and then it's plug in top minus plug in bottom. Okay, that's how you do definite integrals. All right, now, could we actually use a calculator? Yes, you could. All right, take a look. If I go alpha F2, all right, you should be familiar with this. There's sigma, all right, absolute value, log base. What's number 4? When you push number 4, you'll see an old friend, or a new friend, I should say. All you got to do is type it in, and it better say 117. Oh, because I got to put in what? The original. I'm so stupid. All right, what was the original? I believe that was what? 3x squared. Yep. Thank you. Try it again. 3x squared. And that one, I'd better say 117. Amen. All right, guys. That's your calculus lessons for the year. All right. I got nothing but praise for y'all, and hope you learned a lot and had some fun along the way. All right. Remember, my door is always open for you. All right. So come see me next year, and have a good summer. Oh, you definitely. I'll miss you. All right. See you.